The first thing we're going to be looking at with our given equation is whether it is endothermic or exothermic. We can look at the fact that we have negative 2,220 kilojoules. That's going to tell us our reaction is exothermic, as it's a negative number and heat has been lost to the surroundings. And then the fuel value of propane is what we're going to be looking next. Our given information is 250 grams of water was heated over 4.5 grams of propane. The temperature increased from 65 degrees Celsius to 70.8 degrees Celsius. And then the mass of the propane tank after was 4.38 grams. And as we know, we're at that negative 2,220 kilojoules. First, we're going to calculate the heat absorbed by water. So that's going to bring us out to, after our equation here, we're going to multiply our 250 grams times our 4.18 grams per Celsius, and then multiply that by the heat lost. So that's going to bring us to 6,061 joules. And then we need to convert those joules to kilojoules. So we're going to cross multiply here, which brings us out to 6.61 kilojoules. We're going to divide the heat released by the propane, the propane we have left, which is, we're going to multiply the propane we started with from what we had left. So that leaves us with 0.12 grams, which is 50.51 kilojoules per gram is our fuel value of propane. And then we're going to find the limiting reactant, given that we have our mass of our C3H8 is 155 grams, and our mass of O2 is 635 grams. The first step here is to cross multiply given our molar masses. So with our C3H8, we are going to come out to 3.15 moles. And then with our O2, we're going to come out to 19.8 moles. So we have an excess of O2, which shows us that our C3H8 is the limiting reactant of our equation. Next, we're going to calculate the mass of H2O produced. So what we know based off of our balance equation is that 1 mole of C3H8 produces 4 moles of H2O. So we're going to multiply 3.51 moles, which we got up here. That's our C3H8. That's our molar mass after. And then times 4. That's our 14.04 moles. And then we have to multiply that by the molar mass of H2O, which is 18.02, which brings us to 253 grams, which is how much H2O was produced. And then the next we're going to calculate our percent yield. All we're doing here is dividing the 245 grams that we got from the last equation by the actual, which was 250, or the actual, by the actual, so 253 grams, and then we're going to multiply by 100, so we come out to 96.84%. And then lastly, based on our answer to number 3, we're going to calculate the amount of heat produced. So we know we had the negative 2,220 kilojoules. And then our limiting reactant was the 3.51 moles. So all we do here is cross multiply the 3.51 moles by our kilojoules, which brings us to the amount of heat produced was negative 7,792 kilojoules.